Hello and welcome to episode 5 in the series Calculus 101, and today I'm going to be talking about derivative rules. I do recommend you check out my previous video, The Derivative, which simply introduces you to the concept of a derivative, what a derivative is, and how to formally define it. So let's get started. So one thing I hope you remember from the previous video are the two ways of writing a derivative. F prime of x is one, and then the derivative of f of x can also be written as this, with d representing a differential or a very tiny change in. Okay, so the first rule is the multiplication by a constant. Pretty straightforward. So we have the derivative of c, let's say c is a constant, multiplied by f of x, where f of x is the function, can equal c multiplied by the derivative of the function. This is a pretty straightforward rule. So let's say we have something like the derivative of 5x. So we're basically trying to find the slope of y equals 5x. So we can say this is 5 multiplied by the derivative of x. We know the derivative of x, or basically the slope of y equals x, is simply 1. So we can say this equals 5. Once again, this is obviously quite known to us. Y equals mx plus b tells us the slope should be 5. So this wasn't some extraordinary rule, but just showing you a little bit how it works. Rule number 2, the sum rule, which basically states the derivative of f of x plus or minus g of x is equal to the derivative of f of x plus or minus the derivative of g of x. Pretty straightforward, which basically means if we have this plus this, we're going to be having the derivative of one plus the derivative of the other. And if we have this minus this, it's simply going to be a subtraction. The product rule. The product rule basically states the derivative of f of x multiplied by g of x equals. So that's going to be f prime of x multiplied by g of x plus f of x times g prime of x, which is basically the derivative of the first function multiplied by the second function plus the derivative of the second function multiplied by the first function. Let's take an example. Let's say we have something like this over here. Once again, you can easily simply just multiply them together, but obviously they're not always as simple as this one that I've given here. So the f prime of x will be 5, as we saw from the previous example, multiplied by 2x plus g prime, which will be 2 because the slope of g of x is going to be 2, multiplied by 5x. So once again, you can simply multiply them together. However, sometimes we get harder questions like this. And now, what do we really do? Obviously, this is just making it way harder, but in essence, this is obviously a very easy question that we're going to get, but just to show you an example of what the product rule is, hopefully that helped. So now, the quotient rule. So this is actually a little bit tricky because it's not as simple as saying f prime of x times g of x minus f of x times g prime of x. It's actually a little bit harder than that. And that is because if we, let's say, have something like this over here, we're basically trying to say f of x multiplied by 1 over g of x. And then we can use the product rule. And if we do that, you will see that it's not as straightforward as simply saying minus. So this is actually going to equal something quite weird. Now, you don't have to memorize this because once we actually start getting through with derivatives a little bit better, this may make way more sense to you. But in essence, what it's going to equal is the f prime of x multiplied by g of x minus f of x times g prime of x. This is very similar to this except for the minus. But here's where things get weird. Divided by g of x squared. I know it's a bit weird, but if you actually evaluate this over here using the product rule, you will get exactly this. And this is just a simple way to write it down. Now, once again, I know this may seem like too much. Oh, these rules, kind of pointless. But believe me when I say this definitely does help, because you can use this in some examples, but when you get to really hard examples, this really starts to break down using this in the product rule, because then it just becomes too hard, because then you have to differentiate 1 divided by a function, which is a whole nother rule. So let's not get too deep into that, and I'm just going to suggest this should explain it all. Now, I don't want to confuse you a little bit too much, so I'm not going to be doing an example with this, but in the next video, I am going to be doing derivative examples, so maybe that will clear up your mind a bit. But for now, in this video, all I want to do in this video is simply give you the rules, such that you can maybe write it down and wait for the next one in which we actually solve a few examples. So now we come to the power rule. This is actually quite an important one, which states the derivative of x to the n equals nx n minus 1. So basically, let's say we have the derivative of x squared, much like we did in the previous video. We can simply say bring 2 down, x, and 2 minus 1 will simply be 1, so 2x. Once again, if you remember in the previous video, I think I took the entire whiteboard up to actually prove this using limits. But now, as you can see, we can simply do it in 1 step. It doesn't even require a line. You can do it on the same line. It's that easy. So using derivative rules, it definitely does help us in the process of differentiating any function. And now this is really the one where some people get confused, because the chain rule is really the hard one. So what this states is the derivative of f of x compose g of x, well, these are composite functions, so you can also write them as this, which may make more sense because you may have seen this more likely than this. So f of x compose g of x equals the derivative of f compose g of x multiplied by g prime of x. Now, because this is so weird, I'm not going to wait for the next video to give you an example and give you a small example right now. Not too hard, but hopefully it should help. So let's say we have the derivative of 2x squared plus 5x, the whole to the 4th power. How would we actually solve this? Now, sure, you can simply actually take it to the 4th power and then just simply use the other rules that I've showed you, but that's a little bit too tedious. And let's say this is -5. What are you going to do then? So what we do now is simple. The first thing we must do is identify g of x and f of x. So if you've learned composite functions, which I really do hope you have if you're starting calculus, we can say that this over here can be g of x. So g of x can be 2x squared plus 5x, and f of x can be x to the 4th. So if we're taking f compose g, we have to simply place this entire thing into that, and we get this right over there. So how would we solve this? Well, the first thing we must do, once again, as you can see, we have to take f prime of g of x. So what does that really mean? So what that means is we take the derivative of the inside, keeping the outside the same way. What basically that means is we are taking this right over there. So what do we have? So using the product rule, the constant rule, and all the rules that we've learned in this video over here, we can say that the derivative of that is going to be 4x, simple power rule. So we have 4x. Now, because of the sum rule, I can say the derivative of this plus this is the derivative of this plus the derivative of this, so plus 5. So we've successfully taken g prime of x, and now we have to multiply it by f prime of g of x, which basically means take the derivative of the outside with respect to the inside. So what we have is take this entire thing, which is x to the 4th power, and take the derivative of that, which is basically now going to be 4, because you're taking the 4 out, multiplied by 2x squared plus 5x to the 3rd power. Well, how did I get that? So this right over here, I got from that. So taking x to be this entire function over there, I simply brought down the 4, and 4 minus 1 is 3. So I can evaluate that over there. So then I can say that this guy, which is g prime of x, multiplied by that guy, which is this over here, equals the derivative of this. This one was a little bit Spicy. I know this is a little too much to give you on the first introduction to derivative rules, but personally I believe that this is quite a good introduction, getting a little bit deeper into the chain rule, because this is maybe one of the most important rules in differentiation. So what we've basically done over here is simple. Let me just reiterate that. The first thing we must do is take the derivative of the inside, which we did over here, 4x plus 5. How did I get 4x plus 5? Because I used the power rule. I brought the 2 down, multiplied by 2 by 2 to get 4, and 2 minus 1 is 1, so 4x. How did I get 5? Because the derivative of 5x, or the slope of y equals 5x, is simply 5. That was pretty easy. The next part is the most confusing part. So then I take this entire function inside to be x, and I differentiate it with that being x. So 4 multiplied by x to the third, because the derivative of f of x would be 4x to the third, right? From the power rule. So same thing over there. I really do hope that made some sense. You understood a little bit about derivative rules, because this over here is very important. So as you've seen over here, I have utilized most of the derivative rules that I covered in this video in this one example. My next video is going to be some examples on derivative rules, so hopefully that should cover things up a little more than this one did, because the primary purpose of this video was to give you an insight or just an introduction to the rules of differentiation. I do hope you enjoyed that video, and until next time, stay sharp.